Balancing chemical reactions. In this lesson, we're going to be going over balancing chemical reactions, rules for balancing, what not to do, and then a whole lot of practice. Balance chemical equations. Atoms cannot be created or destroyed in a reaction. All the atoms that we start with, we must end with in the end. A balanced equation has the same number of each element on both sides of the equation. So you'll notice in the diagram on the right, we have 3 blue circles on the left, and we have 3 blue circles on the right. We have 1 red circle on the left and 1 red circle on the right. What we have at the beginning, we need to have at the end. This is a balanced chemical equation. Chemical reactions. While the reactions show what is used up and what is produced, they do not reflect the proper number of each type of atom required for the reaction. So the example of this is this H2 plus O2 gives us H2O. This tells us which reactants are being used to produce which products, but not the number of reactants for the reaction to go forward or the amount of products that are produced as a result of the reaction. So in this example here, how many oxygen atoms are on the right? The oxygens are going to be the pink, and we're going to have 1. How many oxygens are on the left? There are 2. And that's a problem, because now we're saying that we have less oxygens in the end than we started with. And since atoms cannot be created or destroyed, there's something wrong with this. So this doesn't make sense. So what happened to the other oxygen atom? Nothing actually happened to it. And we're going to see on the next slide what we need to do to fix it. So how do we solve this? Well, we're going to put coefficients to balance the equation to ensure that there's the same number of each type of atom on each side of the equation. So we take a look at our chemical equation right here. H2 plus O2 equals H2O. Now what we need to do to balance it is that we need to add more reactants and more products as a result. So you can see in our diagram, this was our original diagram here. But that wasn't right because we had 1 pink and 2 pinks, which doesn't work out. So what we needed to do is we needed to add another set of hydrogens. And if we add another set of hydrogens, that allows us to make a second water molecule. Now what does this look like in our chemical equation? Well, we're going to add a 2 in front of the H2 and a 2 in front of the H2O. This 2 in front of the H2O represents that we have 2 H2Os on the product side, and this 2 beside the H2 represents that we have 2 hydrogens on the reactant side. Then we need to check to make sure we've done everything right. So on the left-hand side, the hydrogens, there's 2 in the coefficient times 2 hydrogens per molecule, and that's 1, 2, 3, 4 hydrogens. For the oxygen, it's just 1 times its 2, the subscript right there, equals 2. On the right-hand side of the equation, we're going to again have 2 times 2 hydrogens, gives us 4. And now we're going to have 2 times 1 oxygen, gives us 2. And we're going to compare them. Hydrogens have 4 each, oxygens have 2 each, so we're good. Now what we need to keep in mind is that the coefficient doesn't actually change the reaction. It simply shows us how many reactants were needed to produce this many products. Rules for balancing. First, we're going to assemble the correct formulas for all the reactants and product. Number 2, we're going to count the number of atoms of each type appearing on both sides. Number 3, we're going to balance the elements one at a time by adding coefficients. That's the number in front. And we're going to add those when we need more. And we're going to save balancing H and O until last. And I generally like to save O until the very last. However, if there's any element on its own, let's just say that there was an Na on its own, that would be the one that we always leave last because it's super easy to balance. We can put any number in front and we don't need to worry about doubling up or messing up everything else on the other side of the equation, which we'll see as we move on. And then we're going to double check to make sure it's balanced by counting the atoms on both sides. What we're never going to do is we're never going to change the subscript to balance an equation. We can only change the coefficients. If we change the subscript, you're actually changing the formula and describing a different chemical, keeping in mind that H2O is different from H2O2. We're never going to put a coefficient in the middle of a formula either, so they only go in the front. So 2NaCl is okay, but Na2Cl, that is not okay. Check your understanding. In more complicated chemical reactions, we may want to use a chart in order to keep everything straight. So let's use the example of CH4 plus O2 gives us CO2 plus H2O. So our first chart here on the right-hand side, we're going to list their elements, C, H, and O, and then we're going to write the before, that's the reactant side, and the after, that's our product side. So if we count the carbons on the reactant side, we have 1 carbon, so we write 1. On the product side, we have 1 carbon, so we write 1. Hydrogens, there are 4 hydrogens on the left-hand side, and there are 2 hydrogens on the right-hand side. The oxygens, there's 2 on the reactant, and 2 plus 1, so 3 on the product side. So let's pick one and fix it first. Let's start with hydrogen. So to fix hydrogen, we have 4 before and 2 after. So we're going to put a 2 in front of the H2O. That's going to adjust the hydrogens and makes it so there's 4 after as well as 4 before. The oxygens, we had 2 before and 3 after. But after we added the 2 in front of the H2O, now we have 1, 2, 3, 4. And we have 2 on the left-hand side. And our carbons weren't changed, so 1 and 1. So now let's fix oxygens, our last one. So since we have 2 on the reactant side and we need 4, we're going to put a 2 in front of the O2. Now when we take a look at everything, carbon still has 1 and 1. Hydrogen still has 4, and 2 times 2 is 4. so 4 and 4. And now our oxygens have 2 times 2 is 4 on the left-hand side, and we're going to have 2 plus 2, 4 on the right-hand side, and we're balanced. Check your understanding. I want you to pause the video and answer this question. Okay, so how do we do this? Well, let's check out before and after at the very beginning. So nitrogens at the beginning, there's 2, and after there's 1. Hydrogens, there's 2 in the reactant side and 3 in the product side. So we got to pick one to balance first. Let's balance nitrogens. So we're going to put a 2 in front of the NH3, and what that's going to do is that's going to change this nitrogen from 1 after to 2. It also affects the hydrogens because now there's 2 times 3. So now there's 6 hydrogens on the right-hand side. So now we need to fix the hydrogens. So let's put let's put a 3 in front of the H2. And when we do that, we get 6 because we're going to get 3 times 2. So now we're balanced. We have 2 nitrogens, 1, 2, and 1, 2. So nitrogens are good. And our hydrogens, 3 times 2 is 6, 2 times 3 is 6. So our hydrogens are good too. Check your understanding. One strategy that I like to use is if you see a polyatomic on the left and on the right-hand side, you can balance it as a polyatomic, and you're going to take care of 2 or 3 elements all at once. So in this case, in the first example, we're going to see NO3 on the left-hand side, and we see NO3 on the right-hand side. That's a polyatomic, and we can balance it as is. So if there's 2 NO3s on the left-hand side, we're going to put a 2 in front of the KNO3 on the right-hand side. That's going to take care of our nitrogens. So what are we going to look at next? Well, let's pick potassium. There are 2 potassiums on the right-hand side. We know 2 times 1 on the right-hand side. So now we're going to put a 2 in front of the Ki on the left-hand side. So the potassiums are balanced. Let's pick our next element. There are 2 I's, 2 iodines on the left-hand side, and 2 iodines on the right-hand side. So it's good. The only element left is Pb. There's 1 Pb on the left, 1 Pb on the right. So we are good. You'll find as you go through balancing that a lot of it is trial and error. You pick an element, you balance it, it might mess up the balancing on another element, but then you just go back and you fix it, and you just go back and forth until you get everything balanced. And then, of course, you check. So let's do a quick check here. So our elements that we have are Pb, N, O, K, and I. On the left-hand side, there are 2 I's. On the right-hand side, there are 2 I's. On the left-hand side, there's 1 Pb. On the right-hand side, there's 1 Pb. On the left-hand side, there's 2 nitrogens, right? Because that 2 goes to there. So 2 nitrogens. And on the right-hand side, there's 2 nitrogens because 2 times 1 there. Oxygens on the left, we have 3 times 2, so we have 6. And on the right-hand side, 3 times 2, we have 6. Potassiums on the left, there's 2 times 1, so we have 2. And on the right-hand side, there's 2 times 1, so we're correct. Let's take a look at the second one. So now, once again, we're just going to pick an element to go with first, and we're going to balance it. So let's try sodium. So sodium on the left-hand side has 1, and on the right-hand side it has 2. So we're going to put a 2 in front of the Na on the left-hand side, and that's going to balance sodiums. So we're going to write 2 and 2. Now let's pick carbon. On the left-hand side, there's 2 times 1, there's 2 carbons, and on the right-hand side, there's only 1. So we're going to put a 2 in front of that carbon, and we're going to balance that up. And now we're going to double check. Did that mess up our sodiums? No, because we put a 2 over on the right-hand side where there's no sodium, so sodium is still good, or Na. Now we're going to pick another element. Let's pick a polyatomic. So we have SO4 on the left-hand side, we have SO4 on the right-hand side. That works. They both only have 1, so that's probably not going to be advantageous for us. It's probably not going to be a strategy we're going to use. So let's just get past that because they're both 1s. So let's pick another element. Let's just pick S, so sulfur. 1 S on the left, 1 S on the right, so our sulfurs are good. Let's do hydrogens. Hydrogens are going to be a little bit more complicated. On the left-hand side, there's 2 times 1, it's 2, plus the 2 right there. So on the left-hand side, there's 4. On the right-hand side, there's 2, and that's it. So let's put a 2 in front of that, and that's going to balance off the hydrogens. Now, it didn't affect any of the other ones we've done so far, so we don't need to worry about going back and fixing it. The last element we have is oxygen. Now, on the left-hand side, we're going to have 2 times 3 is 6, plus the 4. So we're going to have 10 oxygens. On the right-hand side, we have 4 plus 2 plus 4, which is equal to 10 as well. So the oxygens are good. So everything is good. Each element has the same number on the left as they do on the right-hand side. Check your understanding. So I want you to pause the video and answer these 5 questions. So for the first one, let's start by balancing our polyatomics. So we have an NO3 on the left. We have 2 NO3s on the right, so we're going to put a 2 here, and that's going to balance the NO3s. That 2 Ag is then going to be balanced by putting a 2 here. We have 1 copper on the right, 1 on the left, so the first one is complete. For the second one, magnesium, there's 3 on the right-hand side, there's 1 on the left, so we're going to put a 3 there. The nitrogens are already balanced. We have a 2 and a 2. For question number 3, We have 4 phosphorus on the right-hand side. We're going to put a 4 here. There's 10 oxygens on the right, so we're going to put a 5 there. 5 times 2 is 10. For the fourth one, let's start by balancing hydrogen. There's 2 hydrogens on the left, and 2 plus 1, 3 on the right-hand side. Since we have an odd number on the right-hand side, let's make this a 2 to make that an even number. 2 times 1 is 2, plus 2, there's 4 hydrogens on the right, so we're going to put a 2 there to balance our hydrogens. Now we've changed our sodiums. Now, by doing that, we've changed our sodiums. We now have 2 sodiums on the right. We need to put a 2 here, so now we have 2 sodiums on the left-hand side. Now we're just going to make sure everything is good. We have 2 sodiums on the left, 2 on the right. We have 4 hydrogens on the left. We have 4 hydrogens on the right. We have 2 times 1 oxygen on the left. We have 2 times 1 oxygen on the right. So we're done. For the last question, let's start by balancing hydrogen. We have 4 hydrogens on the left. We have 2 on the right, so we're going to put a 2 there. Now we have 4 hydrogens on the right, 4 on the left. We have 1 carbon on the left. We have 1 on the right. And we have 2 oxygens. 2 plus 2 times 1 is 4. So we need to put a 2 here. So now we have 4 oxygens on the left and 4 on the right-hand side. So as you can see, there's different ways of balancing chemical equations. As you do more practice, you're going to come up with your own strategies and you're going to get faster. The best advice I can give when anyone is balancing any equation is to just start. Pick an element, balance it, and then move on to another element. Go back and forth until everything is balanced. Once you're done, make sure you double check to make sure everything is correct. And if you follow all these steps, you'll find balancing isn't that bad. And that concludes our lesson on balancing chemical equations.